I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is Unit 4, Lesson 4 for Algebra, Writing Inequalities. So when we're writing inequalities, we need to make sure that we know some keywords that to look for to know what inequality symbol to use. So for less than, you may also see fewer than. For less than or equal to, you'll see a lot of times at most. For greater than, you may see more than. And for greater than or equal to, you may see at least. Now, that's not obviously all of the keywords you may see, but those are some of the major ones. So we're going to start with a simple problem. You must be at least 16 years old to get a driver's license. So if I were to write an inequality to model that, then really I would just say that x has to be greater than or equal to 16. If I go back up to here, here's at least, that's the greater than or equal to symbol, right? If you think about it, at least 16, I like to say, okay, so is that 15 or is that 17? At least 16, that means 17. Well, could it be 16? Yes. So that's where the equal to comes into play. So that's just a one variable inequality, like you could graph that on the number line. Let's move on to a two variable inequality. Breakfast at Houston Christian costs $4 and lunch costs $6. Your parents give you $75 a month to spend on food at school. Write an inequality to represent how many breakfasts you can buy and how many lunches you can buy. All right, so in order to do this, we first need to identify our variables. And so I'm just going to call them x and y just because those are my favorite. So I'm going to say that x is the number of breakfasts that I buy. I know how much they cost. I don't know how much I'm getting. And then y is going to be the number of lunches that I get. So again, that is what is unknown. What I do know is the cost of each of those. So if my parents gave me $75, that means I have $75. So I could spend $75. Could I spend $76? No, they only gave me $75. So it's going to be less than or equal to $75. You see, there's not any particular keywords in here. It's just that we understand what the problem is telling us. So something, however much we spend has to be less than or equal to 75. All right, well, how do I figure out how much I spent on food? Well, if breakfast costs $4 each, then I'm going to multiply 4 times the number of breakfasts that I get. And if I also buy some lunches, I need to multiply my lunches by 6. So the y gets multiplied by 6. And if I multiply and add that up, that's going to tell me how much money I've spent on food at school. And that number needs to be less than or equal to $75. So there is your inequality. Notice that this inequality is in standard form. AX plus BY equals C. That is standard form. And we could graph it that way, but remember we can also rewrite it in slope-intercept form and graph it that way. So that's what I'm going to do. 4x plus 6y is less than or equal to 75. So I'm going to solve for y. So I'm going to subtract 4x on both sides. That leaves me with 6y is less than or equal to 75 minus 4x. I'm going to divide by 6. My inequality symbol does not change. I did not divide by negative. And then I have 75 divided by 6, which I could just leave as 75 over 6. But also, it divides pretty well, and that is 12.5. So I'm going to go ahead and write it as 12.5. And then I have negative 4 over 6, which simplifies to negative 2/3 x. So there is my inequality. Y is less than or equal to 12.5 minus 2/3 x. And the reason this is helpful is because now I can graph it on the coordinate plane and I can really see my solutions. All right, so my slope is negative 2/3 and my y-intercept is 12.5. So I first need to find my y-intercept, which is right there, 12.5. And then I need to go down 2 over 3. Now, because I'm at a half, I need to pay attention to that when I'm doing my slope. So when I go down 1, I'm really going between 2 lines because I started at 12.5. So if I go down 1, I'd actually be at 11.5. So I'm going to go down 2 over 3. So 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Now, is that a dotted or a solid line? Well, it should be a solid line because of the equal to underneath. So I'm going to go ahead and make that a solid line. And I need to figure out where I need to shade. Looks like I need to shade below because it is a less than. So my solutions are this shaded region. Now we really need to think about what does this graph mean. And so if I think about what is on the x-axis, well, we said that x was number of breakfasts and y is number of lunches. So this is number of breakfast and this is number of lunch. These numbers and these numbers are negative numbers. Am I going to buy negative breakfasts? Nope. Am I going to buy negative lunches? No. So that is actually irrelevant. Okay, these solutions are not relevant, nor would these solutions be relevant because it doesn't make sense for this real world problem. So the only solutions that I'm really concerned with are the ones in this green shaded area. All of this is what I'm concerned with because those are the positive solutions. So let's talk about some solution values. So this point is clearly in the shaded region. What does that solution mean? That means that I bought 5 breakfast and I bought 3 lunch. So 5 breakfast, 3 lunches. That is a possible solution. Another possible solution is this guy right here, not quite on the line. That would be 3 breakfast and 10 lunches. 3 breakfast, 10 lunches. Now these points that are on the line, those are at half marks. Can I buy half a lunch? I don't think I can. I can get like a side, but we're not really talking about that. So those points don't really mean too much because again, I'm not going to buy half a lunch or half a breakfast. Right now I'm just talking about getting either a meal or not a meal. So any point in this solution area would be a solution, and you have to think about what is the x-axis and what does the y-axis represent, which is why it's so important to identify your variables when you start the problem. Lastly, I just want to point out that we did not have to graph this in order to find solutions. 4x plus 6y is less than or equal to 75. I could really just kind of guess and check. So I could say, okay, what if I bought 3 breakfast and then I want to know how many lunches can I buy? I could solve for y like that. Could solve for y. 12, 4 times 3 is 12, subtract the 12, divide by 6. Or you could just guess and check and say, okay, I'm going to do 4 times 6, and then I'm going to do 6 times 4, and I'm going to see if that's less than or equal to 75. And so you can check solutions that way.
I've been waiting way too long.